Hi, everyone. Welcome on. This is the last session or the last webinar of session number 2 for the Kubernetes series. So thanks for sticking with us. We have a lot of great content coming and excited for the next one as well already. As a quick housekeeping reminder, the session is being recorded. We are posting the recordings on YouTube, and they'll also be emailed to you if you registered for this event. So by being here, you'll make sure to get that. And it'll also be the same link for session 1. So if you missed our intro to Kubernetes back in February, you can go ahead and catch up there as well. Please keep all of your questions in the Q&A. This helps our panelists better answer them, and we can also get follow-ups if needed. And with that, I'm going to kick it over to you, Hugo. Thanks.
Thanks, Erica. Welcome everyone to the final session of the day. Hopefully you've had a chance with that longer break. We wanted to give you a longer break because this is probably the most detailed session where we go a little bit more deeper into CI/CD and how VCF uses open source projects. So those VCF services that we mentioned in the prior 2 sessions, how we use those to create CD, CI, and a bunch of other things as well. So my name's Hugo. I work in the VCF division as a technical product solutions architect. And I focus mainly on enabling ecosystem tooling and best practices for designing and implementing and adopting VKS within VCF. And I'm joined today by Miles. Miles, you want to do a quick hello to everyone? I think you did it previously, but it's no harm doing it again.
Yeah. You might know me from sessions such as the last one. I work in tech marketing and I'm focused on anything apps, Kubernetes, and above.
Awesome. So for this session here, what I want to do is introduce you to a new concept called the consumption models for VKS. This is part of the design libraries that we have within the tech docs. So the link that Miles and I, flashed up on that QR code, hopefully you've had a chance to take a look at that. If not, don't worry, we've got that QR code in this session as well. So I'll go over what are the consumption models, and Miles will then take us through GitOps practices and principles, basically what that is. And we'll do a deeper dive into ArgoCD and how we can use that as an app of apps pattern to lifecycle manage VKS clusters and also install add-on packages and also deploy an application and also do a bunch of other things, right? We have a nice demo presented by Skand Purohit. I'm going to press play on that demo towards the end to go through that Argo workflow. So you have a much deeper view of what that looks like. And then, of course, we also have all the code that we're going to be covering in today's session on our GitHub repository as well. So hopefully you guys can take a look at that towards the end, give us feedback for follow-up sessions and so on. Miles will monitor the Q&A. So if you have any questions, please use the Q&A and let's make this interactive. So, Miles will interrupt me and I'll interrupt him, and we'll hopefully get this session, underway and of interest to you. So let's get cracking. So why did we embark on doing these consumption models and enabling, I guess the gaps that we hear from our customers and our partners around, hey, we have these tools, right? So my customer uses EKS or OpenShift or Rancher or AKS. And the customer is already using these solutions, right? So for example, for observability, they're using Dynatrace and Datadog. They might be using a third-party PaaS platform for CI and CD and a bunch of other things such as Harness. They might even be using Tekton or Flux CD or, I can name a bunch of tools, and so can Miles. I think Miles did mention those tools in the previous session as well. And the main feedback is we're not in pain with these tools, right? We're in pain with how do I get VKS running on VCF, then how do I integrate VKS and the wider ecosystem of modern applications on VCF into my current CI/CD /GitOps /DevOps ecosystems. All right. So this is why we came up with a design library. So the design library has a bunch of consumption models, and those models aim to rectify the question about, what about my existing tools? Okay. So the consumption model includes architecture patterns. So you'll see architecture guide, which contains, design diagrams, high-level overviews, why we're doing this, and the components that are part of the consumption model. We also provide a full GitHub repo, so you can basically clone or fork that repo, bring it into your own repo, and then run against the configurations within that repo as well. So we validate the repo, the GitHub code, the architecture patterns, and the design guide with only GA specific releases of all of the VKS services and also of VKS. So we're not doing anything that you can't do today with the current code that we've released from a general availability standpoint. So what is it not? So the design library is not just documentation. It's actually not core documentation if you think about it. So it's not product documentation. It doesn't explain what a feature does. It doesn't reference all the pages for all the components. What it is it shows how real teams can use VKS end to end as part of that bigger ecosystem pipeline. We provide those architecture patterns for those use cases. And so just to delve into slightly the use cases that we are thinking about, we're doing CI/CD as VKS as a landing zone for applications once they've been deployed by a Helm chart, or even with ArgoCD or FluxCD or Harness. And also VKS as a landing zone for doing CI pipelines, right? So image builds, unit testing, a bunch of stuff that you can do. VKS will be able to be that Kubernetes clusters that, those things can consume. So the GitHub repo it has the sample code. You can ready to run, ready to demo, and built around tools customers already use. Right. If you look at the repo from the previous session, we had a QR code. I'll post it again in a minute. We're using like the large e-commerce application, which has a load of microservices. It uses pretty much every single thing you kind of have if you were delivering a production type modern application, right? It has ingress, it uses certificates, it uses persistent volume claims, it is distributed across multiple replicas, across multiple Kubernetes nodes. So when you run it, you'll see it running, you see what it uses, and you see it uses all of the capabilities provided from VKS. So the design library is also validated against GA products, as I mentioned before, right? So we validate this, you can run it and test it and enjoy what we've done, right? So what's currently available today? So today we have CI/CD with ArgoCD from an application deployment point of view. So what that means is you have ArgoCD managing applications that you've defined in Argo, and then you deploy those applications into VKS clusters running on VCF, right? We also have a similar pattern with a third-party PaaS solution called Harness. So Harness is basically quite a good product and solution where you can integrate with a bunch of other things, including like it has modules for observability, modules for security scanning, and so on. So we've demonstrated that as a consumption model, i.e. an architecture pattern that you consume Harness if you're already using Harness in your organizations, to then consume VKS as the underlying Kubernetes clusters. All right. So the intent is for organizations that already have these tools to basically not change your ecosystem tooling, but to keep your current ecosystem tooling, right, and deploy into VKS instead. So we're also working with other vendors and partners. So at the bottom there, you see in-flight customer partners such as Wiz, Dynatrace, We're looking at inner loop and developer environments as well. On the roadmap, we have GitLab and GitHub Actions. And then additionally, from observability standpoint, Datadog. We've also released Cosmonic as a solution that runs into VKS for WASM as well. So also check that out. I've got links to all of these in the slide deck here. So let me take you through what it looks like for CI/CD with VCF tooling. All right. So in the previous session, Miles and I discussed CI and why don't we have many CI things in VCF? Of course, that's coming. So please look out for upcoming VMware Explore sessions, right? So for the purposes of this session here, and also for the GitHub repository, and also the consumption model that we've released recently, we're using GitLab CI as the CI component, and we're using ArgoCD for the CD component, right? So here you've got a developer, he updates code that gets pushed to the repo. We have a CI pipeline that updates the code, creates a new container, and then pushes that to the image repository there. So that repository can be Harbor, which is a VCF service, or it can be anything else that you're already using, right? So in this example, it could also be JFrog Artifactory. And then from a CD standpoint, we have Argo with an application that's been configured that constantly looks at that repo and updates and deploys that application if there are any changes, for example, right? So that gets deployed into the VKS cluster on the right-hand side there. And you see all those VCF services, these little icons here, that we're using. So Cert Manager, Istio, Contour, etc., in order to provide the additional capabilities that are provided within VCF and VKS. And then just to finish off on the left-hand side, so that was a developer viewpoint. On the platform engineer persona, you can also create this VKS cluster with Terraform or OpenTofu using the API within VMware Cloud Foundation's automation portal as well. So that's one use case of this. Miles will cover a different use case later on, and we have a demo on actually using ArgoCD to lifecycle VKS clusters, right, on VCF. So how does then this look like with third-party tooling? So third-party tooling, a bit more complex because we've added a lot of those capabilities and tools that I spoke about, mainly with Harness, right? So we've chosen Harness because we've got a Harness and Broadcom have a lot of mutual customers that use Harness and then also use VCF. And then what we want to do is just combine the two so that these customers that are using Harness as part of their CI/CD ecosystem can also use VKS, right, within that ecosystem as well. So again, we have the developer commits code into their repo. Harness picks up that and does all the things that Harness does very well. So it does vulnerability assessments, SAST, secret detection, integrates with Dynatrace, and also HashiCorp Vault as well for secrets. And then at the end of the day, you've got these things happening within Harness, right? And you notice here that there's nothing VCF, nothing VKS yet. So when does VKS come into this pipeline? Well, it comes into this pipeline when we have a VKS cluster for that build cluster, right? So you got a build namespace. That image gets pushed and deployed into the build namespace in the VKS cluster. Those images are built. Once they're done, they've been security scanned, etc. That then gets recommitted back up into the repository. And then the CD component within Harness then deploys that application or even updates that application into the VKS cluster on the right-hand side. So it's exactly the same application that we're using for both the previous slide, which is the Argo with the VCF tooling, and now we're just doing the same thing with a third-party product like Harness. All right. So Miles, is there a question? I think you're on mute, Miles. Unmute.
Sorry about that. So does it mean that both ArgoCD and Harness are supported by Broadcom, so covered under support and maintenance?
So ArgoCD, since we package ArgoCD as a service within VCF, so Broadcom supports ArgoCD for that context, right? Harness is, of course, supported by Harness. So if you have an issue with, I don't know, the STO module with Harness for the vulnerability assessment, of course, that's Harness's business to work with Harness and their partners to define, like with Wiz, for example, for that particular support. Now, because we install the Harness delegate inside these VKS clusters, we will support like the running of that delegate because it's like an agent running on VKS, but then Harness provides the support for that delegate. Does that make sense? So let me carry on. So on the consumption models here, so here's the QR code. If you press this little plus next to the continuous integration and delivery with Harness, that will open up a number of additional consumption models, right? So within the Harness ecosystem, we've got the architecture, the design. We also have the integration with AWS IAM. If you're using AWS IAM services there, you can actually integrate that with VKS. And then we'll be releasing an additional consumption model for Harness with integration with Wiz and Dynatrace. So basically that previous slide that I covered, we're going to be having that released shortly as well. And on the roadmap, we've got a bunch of other things, as I mentioned before, Tecton, and then also GitHub Actions with GitHub workflows. All right. So I'll hand it over to Miles from here, and he'll take you through the ArgoCD, what it is, how we use it, what the problems are, and how we use Argo to do app of apps with lifecycle provisioning and so on for VKS. Miles, over to you.
Perfect. Thanks, Hugo. Before we get into my section, there's two questions I wanted to address. So one was, what is better, ArgoCD in the VKS cluster or ArgoCD as a supervisor service? Good question. I would argue that ArgoCD as a supervisor service is better because you get support from us for it. But also it's very common to have a centralized ArgoCD instance. So if you have it in your VKS cluster, sure, you could operate that as your centralized instance, but it makes more sense, in my opinion anyway, to operate it at a supervisor level where it's outside the VKS cluster lifecycle. We manage the lifecycle of it, and then you adopt your VKS clusters into that instance. So that's what I would say is better. But honestly, it really depends on your CD and your organization choices. And then there's another one. I have many clients using operators on Red Hat OpenShift. How can VKS compete with that? Great question. As you'll see towards the end, we've been releasing these VKS add-ons, which are very much akin to an operator in Red Hat OpenShift. I'm very familiar with that ecosystem. And all I'll say is those popular packages that you see in Red Hat OpenShift, we're going to be releasing more and more of those, or at least, VKS add-onified versions of those in the future. So we will get there, is what I'll say. All right, so I'm going to get on to my slides. I'm going to try and get on my slides. There we go. Okay. The problem, right? So why traditional continuous delivery doesn't work at scale? So challenge is four challenges, and the problems are around declarative models versus imperative models. So I touched on this in the previous session. Basically, imperative scripts, so a CI/CD script that runs a kubectl apply, a Helm install, those kinds of things generally require credentials to be baked into the script, security problem, but also depending on how how it's implemented, they may not be idempotent. And idempotent means if you create it once and then you do the same command again, will it create a duplicate of it, or will it just reapply over the top? So there's a lot of considerations that go into that. Imperative scripts tend to run on cron jobs as well. They're, spaced apart by however long you decide that you want to run that script. That means that you don't actually get an up-to-date thing until that script runs. That means if there's configuration drift, which is one of the next points, within that time period, you're now in a bad state until the next script runs. And that could be hours. It just depends on how it was set up to begin with. So configuration script is the next big piece. If you have people going in there touching production, our most mature Kubernetes customers will tell us no one touches prod. It's completely automatic. Like if something breaks in there, they have to fix it the whole way through the pipeline, which is the way that you should do it. You can use your rollbacks, use your versioning and stuff like that you get with GitOps. So any manual hot fixes, emergency patches, I'm just going to go into the cluster and fix this one thing. It breaks your configuration, and then you end up with drift in the cluster versus what is the actual desired state. There's no self-healing with scripts because ArgoCD and those GitOps types of systems are declarative. They have controller loops that run that are constantly trying to reconcile against desired state. So if you don't have that, like you're running an imperative script-based system, then you don't have that self-healing. It's not going to try and reconcile a configuration drift. And then the final thing is something that's usually an afterthought, and it's usually because something really bad happened, is there's an auditing gap. So who changed what, when, why did it break? With traditional CD, that's not very clear. You have to do a lot of diving into logs and that kind of stuff to try and figure it out. With more modern ArgoCD type systems, for example, generally any GitOps system, you can see who committed the change. You can see why it was rolled out. So you got end-to-end auditability. All right, so let's get into the next section. Right, so GitOps is a principle, not just a tool. So the 4 principles of GitOps are, number 1, like I said, it is declarative. The entire system, all the way from infrastructure to the app, are defined declaratively. Here is the desired end state. Go make that so. That's a declaration. So that's the much preferred path to take for these kinds of modern applications. Versioned and immutable, because it's based on Git, you automatically get showing for every single commit, you get an audit history for every single commit, and you can do versioning. It says immutable. That's kind of true. Git does let you rewrite histories if you want, so it's not truly like blockchain immutable, but it's immutable enough that it's good for these purposes. Pulled automatically. So instead of you having a script push down to a cluster, say multiple times an hour or a few times a day, where it requires credentials, the ArgoCD agent lives inside the cluster and it reaches out to the GitOps repo that it's been told to monitor and pulls down those changes as and when they happen. It'll still do that based on a cron job, but the cron job is quite tight. It's usually like 1 minute to 5 minutes. It'll pull down any changes, but crucially, it's decoupled from the reconciliation. So the reconciliation is just going on in the background all the time. As soon as there's a change, it gets reverted straight back. So that continuous reconciliation is a benefit of Kubernetes, and that's what the system is built on top of. But that's sort of your GitOps overview. ArgoCD is just one implementation of GitOps. FluxCD would be another implementation of GitOps. They just have different ways of managing them. Right. So, excuse me. Push-based CD versus pull-based GitOps. So again, not to beat a dead horse here, but your traditional push-based CD system, you have your CI pipeline that builds an artifact. Like we talked about this in that last section, that could even be a container image. The pipeline has some cluster credentials. The pipeline runs a kubectl apply with some YAML against it or a Helm install, and it runs against the cluster. So the cluster state is dependent on how reliable the pipeline is. You don't get a decoupling between the pipeline's reliability and your application uptime, which is not necessarily great. There's no self-healing if someone modifies the cluster. Like I said, because it's push-based and it's not reconciling against that desired state, you can get configuration drift if someone logs into a cluster and goes and changes something. Credential sprawl across pipelines, like I said, if something is pushing into a cluster, it requires creds. So those creds need to live somewhere, and you're eventually going to end up with creds all over the place, which generally have cluster admin privileges. You probably don't want that. So a pull-based system, GitOps as a practice, uh, uses, again, your same CI pipeline, building the same artifact and pushing to the same registry. That bit's exactly the same as the push-based one. The difference is that the Git repo is holding your source of truth. The agent lives inside the cluster, so it doesn't need credentials to authenticate against it because it's inside the cluster, and it's reaching out to Git and pulling down changes continuously, like I said, on a 1 to 5 minute delta. The agent is reconciling the actual state versus the desired state. So if Joe logs into the cluster and deletes the service, it will not wait 1 to 5 minutes. It will do it instantly and reconcile it back against its state. I would challenge you to go set up ArgoCD, delete some stuff, and see how long you can make the downtime, because it's very, very hard to have a lot of downtime. Self-heals drift automatically, like I just said, and you don't need any credentials on the cluster. So these are all wins. Right. Let's see. Yeah, so let's have a look into ArgoCD in depth here. It's, like I said in my last session, ArgoCD is a CNCF graduated project. It's one of the most popular ones out there, graduated being the highest tier of CNCF projects. So that means that the Cloud Native Computing Foundation has found it to be mature enough to be a graduated project. It's vendor neutral. There's no single vendor behind it. It's actually made by Intuit, the people that make, I think it's Fastbooks or FreshBooks, one of those accounting pieces of software in the US. So it's not affiliated with a Microsoft or a Google or a Broadcom or anyone. It's a completely independent open source project. It's Kubernetes native. It was invented and run on Kubernetes. As such, all of the configuration for it is done through CRDs, that's custom resource definitions. We'll have a look at some of those later on. It's multi-cluster aware. This comes back to the question that I was asked a little bit earlier. Do you want an ArgoCD per VKS cluster, or do you want a centralized one? You could do it either way, but most people do a centralized one or maybe two, and then have multiple clusters mounted into them. So a single instance can manage hundreds of clusters, and it has some very clever mechanisms around agents that mean that it can scale beyond, because it's not pushing configurations. It's pushing a command to say you should monitor this thing, and the agent then takes care of it. So it's very scalable. And it's got really, really great user experience. The web UI, super nice, really intuitive, nice to use, easy to understand. CLI is great as well, and a mature API, which is the Kubernetes CRDs. All right, so what does an ArgoCD object look like? So this is how you define an object. And we did cover this in my session, but maybe a little bit more of a generic example might help. So this is the core CRD for ArgoCD. So it defines where to pull the manifests from. So what is ArgoCD looking for? Like, where is it looking to get the configuration? Where is it going to deploy them? So what is the target or the destination cluster or clusters that it's going to deploy to? And how do you want me to sync the stuff from that repo, the source repo, to the destination cluster? So if we have a look at these, so you can see the source in the green here, we've got a few things defined. The repo URL, so that's your GitOps repo. So that could be in GitHub, could be on premise on GitLab. Like I say, you could use some open source thing like Forjo or Git. It doesn't really matter. Basically, just give it a Git repository. Doesn't matter where it is. The path is the path within that Git repository that defines where is the configuration. So it's in the root folder called clusters in the CL01 folder within that. So basically, our cluster 01 configuration lives inside this folder. So anything in there, come and apply it to the cluster. And the target revision says main. So that means what is the target branch that we're deploying from? Most people use main. There are other ways that you can do this, like you can use git tags and you can deploy for against tags and that kind of thing. But if you're using a multi-branching strategy like I talked about in the last session, you would change that to main, staging, test. You get the idea. The destination, then we've got two things. So we've got the server, and that's the Kubernetes API server. So if you have a VKS cluster, that would be your VKS cluster API URL. You just paste that in there. And then the namespace is a namespace within that cluster that you want it to deploy to. Authentication is handled on the back end with service accounts and stuff like that. It's a bit outside the scope of the discussion here, but that's how you define a destination cluster or clusters. And then the sync policy is kind of always set up this way, but it's important to highlight it anyway. So automated equals just do it in GitOps mode, automatically reconcile. Prune means if I delete the application, so this ArgoCD application manifest, do you want me to clean up after myself? So if I've deployed an application as part of this manifest and I delete the manifest, before we do anything else, we clean up that application, remove it from the cluster, and then we delete the Argo object. So that means that you don't end up with like stray or orphaned applications and configurations living on your cluster after you've tried to clean up. And self-heal is fairly self-explanatory. If you have a node outage, if someone goes in and, you know, RM-RFs the whole thing or something like that, it'll try and continually reconcile against the desired state. You can turn it off if you want to, but it's almost always turned on. All right, let's have a look. So sync waves, sorry, I keep skipping one slide ahead, my bad. So sync waves are kind of like stages. You could think of them that way. So ArgoCD lets you define a sync wave for a particular application or how you want stuff to be rolled out. So wave 0 could be namespace registration, right? So for example, let's take a vSphere namespace from VKS and register it with ArgoCD, right? That would be step 1. Step 2, or wave 10, so it goes from lowest number to highest number. Wave 10 might be cluster provisioning. So now that we've registered our vSphere namespace, we want to put some VKS clusters inside of it. And because VKS is defined through CRDs like everything else, you can actually create the VKS clusters themselves through GitOps. Like the whole thing, all the way from the cluster itself to the applications on that cluster, can be completely end-to-end automated. And we'll see it in the demo. So cluster provisioning, deploy a cluster YAML, and add-on installs to the supervisor. And add-ons are what I was talking about earlier, similar to Red Hat OpenShift operators. So cluster provisioning, add-on installation, think things like your ingress, cert manager, that kind of stuff. And then finally, wave 20, or the last step, with that cluster provisioned, deploy some workloads on it. So these would be your actual applications. So deploy apps onto the now running VKS cluster. If it tries to go and reconcile wave 20 before wave 10, it'll just fail and continually try over and over again. It's a declarative system, a desired state system. So it will continually try and drive towards the good outcome. So ArgoCD for VKS. So there were some questions about, I want to bring it up here. So what we ship as a supervisor service for ArgoCD is something called the ArgoCD operator. So that is not an instance of ArgoCD. What it is a controller that is looking for a particular CRD. In this case, it would be an ArgoCD CRD. And what it will do is it will roll out an instance of ArgoCD for you. So think of it as like ArgoCD as a service. So the operator gets installed, then you as a platform engineer or whomever goes in, you create your Argo object on supervisor, and it will automatically go and create the ArgoCD instance for you in the target namespace that you specified. That's really nice because it also LCMs all of those instances as well. Really, really powerful pattern. It makes it easy to have multiple instances. Some people, companies like to have an ArgoCD instance per team or per subject matter area or whatever. Like there's so many ways that you can do it culturally. The point is that we make it very easy for you to get instances if you want multiple instances. And again, fully supported. So we have a customized CLI for ArgoCD. You might say, well, why customized? We have a good reason for it. We're not just doing it for the crack. And we are actively looking at contributing it back to the open source as well. So by default, the ArgoCD CLI uses cluster role bindings. Those are cluster wide. On supervisor, we want to enforce tenancy. Therefore, we don't allow cross namespace objects to be created by users for safety. So we customize the CLI. So instead of cluster role bindings, it creates a standard role binding and allows you to do cross namespace registration. Simple as that. That's the only change there is. And that's why you should use the customized one, the ArgoCD CLI that we package. All right, the app of apps pattern. This is what Hugo was talking about earlier, and we'll look at it in the demo very shortly. So we get one root application and everything is deployed from that. So this is a really, really powerful pattern. So basically you can see I've got this root app.yaml. I do a kubectl apply -f root app.yaml. And then what that does is goes and creates the registers the ArgoCD names, the vSphere namespace with ArgoCD, spins up 2 VKS clusters, and then spins up some workloads on the cluster from a single command. So end-to-end cluster provisioning, application deployment, all managed through that single command because it's all declarative. So if we look at how that works, it's tied into this VKS add-on section because we use add-ons in here. Like I said in the previous section, we've got some centralized ones, ArgoCD, Harbor, Contour, OpenBio, and some distributed ones on VKS clusters. We call them VKS add-ons, so Cilium, FluentBit, Prometheus, Telegraph, those kinds of things. But the interesting piece is in this app of apps pattern, inside of one of these directories, what we're defining is not just a cluster. So we take the vSphere namespace, we register it with ArgoCD, we deploy the cluster, but we also define these two add-on installs. And this is that OpenShift operator-like pattern. So we'll have a cert manager add-on and a contour add-on. We define those again in the GitOps repo, just like everything else, and they will get deployed onto the VKS cluster automatically. We don't need to do any more configuration. It's all taken care of. So the VKS cluster itself, it auto registers, installs cert manager, installs contour, and all declared through Git. Hugo.
And it's all declarative. So on the VKS packages, so you think about, I think there was a question on the previous session about this in terms of upgrades, right? So in VCF, as you know, upgrading from one version to the other is tough and it takes a long time. It takes manual work. So in this app of apps picture, especially with GitOps Plus add-ons, when you need to upgrade a package, so Cert Manager or Contour as an example, VKS, as part of this pattern with Argo, will also update the add-on as part of that rolling update. If no compatible version exists, the upgrade pre-flight check doesn't proceed with it, right? So it's a way to ensure that the add-ons, VKS clusters, and the VKS version that you have is aligned with whatever versions that are compatible at the moment.
Yep, perfect. Right, so I think we're getting close to the demo here. I think we've got 1 or 2 more slides.
Just the architecture, Miles.
Just the architecture, great. So this is an overview of the system that I just described. So you've got on the left-hand side, your supervisor services auto-created. So this is going to be your VKS controllers. That's the thing that rolls out VKS clusters. Then there's your ArgoCD operator. That's your ArgoCD as a service thing I talked about. We've deployed an ArgoCD instance. You can see instance 1 here. That does its thing. And what the declaration that you just saw, so that definition of a vSphere namespace registration, VKS cluster creation, add-on configuration, and app configuration is completely driven through ArgoCD. So those package add-ons will get rolled out into that CL01 VKS cluster along with the apps. You might have missed it, but the CL02, we didn't actually deploy any apps on top of, so it doesn't come up with any apps. All you get is the cluster. So you need to declare everything that you want to do. And add-ons is actually quite powerful. You don't need to do a one-to-one relationship between an add-on and a cluster. You can do it based on the labels. So you could say production clusters or any cluster with a environment equals prod label against it automatically gets Prometheus, for example. So that would be any cluster. So you don't need to define it over and over again. Yeah, that's a nice high-level overview of the demo that we're going to go into.
Welcome. This is a live demo of enabling GitOps-driven continuous delivery on VCF using ArgoCD for VMware Kubernetes Service. Here's the challenge I've set for myself. I'm starting from scratch, an empty environment with no clusters and no workloads. By the end of this demo, we are going to have 2 VKS clusters provisioned, essential standard packages installed, and 2 real-world applications running. And here's the constraint. We are going to do all of it with one ArgoCD command. Everything after that comes from a Git repository. Cluster provisioning, add-on installation, application deployment, and cluster registration. All of it would be driven by ArgoCD watching Git and reconciling the desired state. This is the app of apps pattern on VKS, where a single root application cascades into an entire platform. We'll walk you through the Git repo structure, apply the root app, watch the entire cascading in the ArgoCD UI, show you what's happening in vSphere, and then demonstrate day 2 operations, where we're gonna scale a worker and also add monitoring entirely through Git commits. If you're new to GitOps, you will see why it matters. If you already know GitOps, you will see how VKS makes it native to the supervisor. So let's get into it. Let's see the current state of our environment. I'm in the vSphere client looking at the supervisor. You can see the supervisor is healthy. Under workload management, we have the ArgoCD supervisor service installed. That's the operator. And we also have auto attach service installed alongside it. We have one vSphere namespace already created for ArgoCD instance 1. Let's see the pods running in it. So we have few pods running: the API server, application controller, repo server, and Redis. This is the ArgoCD instance. Now let's see the workload namespace. Clean slate. No clusters, no ArgoCD application. Everything we are about to build will come from one Git repository and one command. Let's walk through the Git repository that drives everything. The README explains the overall flow. At the top level, there is a root app YAML, which serves as the single entry point and the only resource we apply manually. Everything else is orchestrated from there. The bootstrap directory contains the child applications. Inside it, the vSphere namespace folder includes the Argo namespace CR, which registers the workload namespace with ArgoCD. This is part of Wave 0, so it runs first. The Argo apps folder defines 2 ArgoCD applications, CL01 app and CL02 app. CL01 app provisions the first cluster, including Cert Manager and Contour add-ons. CL02 app provisions the second cluster with auto-scaling enabled. Finally, the Workloads folder contains 2 additional applications. App 1 deploys Nginx. App 2 deploys Online Boutique, a full application made up of 11 microservices. ArgoCD scans the bootstrap directory and discovers child applications, each with a sync wave that controls everything. Now let's look inside the CL01 directory. It contains 4 files: a cluster manifest built with cluster API, an ArgoCD cluster CR that automatically registers the cluster with ArgoCD once it's ready, and 2 additional add-on install resources for Cert Manager and Contour. When ArgoCD syncs this directory, all 4 resources are applied to the supervisor in a single operation. The supervisor provisions the cluster, the auto-attach service registers it with ArgoCD, and VKS installs the add-on inside the cluster. 1 sync, 4 outcomes. Under workloads, we have our applications, Nginx and Online Boutique. The latter includes 12 deployments, 11 services, and the necessary service account. This is a full application with components like front-end, card, checkout, payment, and shipping. It gets deployed at Wave 25 once the cluster is up and fully registered. We are also provisioning another VKS cluster located in the clusters CL02 folder. This cluster is configured to use VKS built-in auto-scaling capabilities. The VKS cluster autoscaler is an implementation of Kubernetes cluster autoscaler, enabling the cluster to automatically scale nodes both out and in as needed. And finally, we have the root app, the one YAML that starts everything. This is it, an ArgoCD application that points at the bootstrap directory with recurse set to true. It targets the supervisor, it auto-syncs with prune and self fields. When we apply this, ArgoCD scans bootstrap, discovers all child application YAMLs and start the cascade. Now that we have walked through the Git repository, let's move on to building the app of apps pattern. Before we do that, we first need to authenticate to ArgoCD using the CLI so we can interact with the instance and manage applications. Once logged in, it's a good idea to verify the current state of the environment, specifically whether anything is already deployed through ArgoCD. This gives us a clean baseline and helps avoid conflicts and confusion. Next, we'll create our app of apps, which we'll call Bootstrap. This application will point to the same Git repository we explored earlier, targeting the root path where the orchestration begins. By doing so, we effectively telling ArgoCD to take over and manage everything defined in that repo, using the existing ArgoCD instance as the control plane. From the single application, all child apps and resources will be discovered and deployed in the correct sequence. The root app is created. Now let's switch to the ArgoCD UI and watch the cascade. The Bootstrap application is now orchestrating everything. The root app, VKS GitOps root, is actively syncing and scanning the Bootstrap directory. As it does, you can see the child applications being discovered and created in sequence. Inside the root app, we see app of apps pattern in action. The root application is managing 5 child applications, all coordinated through sync waves. Namespace registration is followed by cluster provisioning, while the workload applications remain pending. Now let's drill into CL01 and watch the cluster provisioning process unfold. We also see that the sync wave is targeting our second cluster, CL02, and we can see that it has already started creating the required resources and the object defined in the manifest. While that is provisioning, let's take a look at the infrastructure side. If we switch over to vCenter and navigate to workload namespace, we can see that both cluster provisioning processes have been initiated. In other words, CL01 and CL02 are now being created in parallel, each driven by its respective ArgoCD application and sync wave. This is a good example of how orchestration works end-to-end. ArgoCD applies desired state from Git, and the supervisor translates that into actual cluster resources in vCenter. As the cluster comes online, the next wave like add-ons and workloads will automatically continue in sequence. If we look at app 1 and app 2, their status shows as unknown. That's expected. They are effectively on hold, waiting for their target clusters to be fully provisioned and registered before deployment can begin. This behavior confirms that everything is working as designed. The dependency flow is being respected. Workloads won't deploy until the underlying clusters are ready, ensuring a clean and orderly rollout. Back in the vCenter, we can now see that the worker nodes are fully ready, indicating that both clusters have successfully completed provisioning. Switching over to ArgoCD UI, the readiness is immediately reflected in the deployment progress. The workload applications have now moved forward in their sync waves. App 2, we can see the deployment and service resources actively being created. The same is the case with App 1, where the Kubernetes objects are being applied. This transition highlights the full lifecycle in action once the infrastructure layer, cluster and the nodes becomes available. ArgoCD automatically proceeds with deploying the application layer, ensuring everything comes up in the correct order without manual intervention. Both VKS clusters are now in healthy state, and our applications are continuing to progress as expected. Looking into App 2, it appears the application is fully up and running. From the front-end service, we will take the external IP address and open it in the browser. And there it is, the storefront, a fully functional e-commerce application complete with a product catalog, shopping cart, and checkout flow. All of it is running on VKS, deployed through GitOps, and continuously managed by ArgoCD. Next, we will validate the deployed resources using the VCF command line interface. Running VCF cluster list allows us to see all clusters that have been deployed by a supervisor within the workload namespace. We can also verify the add-ons installed through ArgoCD. Running the VCF add-on install list and specifying the cluster name and namespace gives us the available add-ons or installed add-ons inside the cluster. So this confirms exactly what we defined in Git repository has been deployed in our cluster. Now let's see the true power of GitOps in action by performing day 2 operations directly through Git commits. I'm going to scale the worker nodes on CL01 from 2 to 3. So inside the cluster CL01, here's the cluster manifest. The replica value is currently set to 2. I'll update it to 3 and then commit and push the change. Switching to the ArgoCD UI, you can see the magic happen. ArgoCD detects the change in Git, briefly shows the application as out of sync, and then automatically syncs it because autosync is enabled. The cluster status now shows progressing. Cluster API is actively adding a third worker node. For a platform engineer, they make a change in Git, push it, and the infrastructure adjusts itself automatically. No kubectl commands, no vcenter click, no SSH sessions. That's a GitOps in purest form. Inside the vCenter, we can see that the node pool has updated to 3, and it's actively spinning up the worker nodes. Alright, our CL01 cluster is healthy again, and the additional worker node is fully ready. Next, we'll perform another day 2 operation. This time, we will add Prometheus monitoring to CL01 by simply adding a single file to the Git repository. This is enabled through VKS add-on functionality. ArgoCD will detect the change and sync it to supervisor. VKS will then automatically deploy Prometheus inside CL01, the correct version, fully compatible with VKS runtime, and all the dependencies resolved. No Helm install, no logging into the cluster, and no manual version checks. ArgoCD has detected the drift and is now deploying the additional package to the CL01 cluster. The Prometheus deployment is currently in progress. We can also use the VCF CLI to validate this deployment, confirming that the package is being applied and the cluster is updating as expected. We have now reached the end of our demo. So let's recap everything we have accomplished. We started from scratch, an empty workload namespace. From a single YAML file root app, ArgoCD orchestrated everything automatically. That one command triggered 5 applications, a vSphere namespace, 2 VKS clusters. Using add-on management, we deployed Cert Manager and Contour, and finally 2 workload apps that were deployed on CL01 cluster. In the second half, we demonstrated day 2 operation entirely through Git, scaling worker node, and adding an additional package for monitoring. So every change is a Git commit, every state is auditable, and any drift is automatically corrected. That's GitOps in action on VKS. Thank you.
Hope you enjoyed that demo. That was by Skand. So we'll just finish off, and Miles, over to you.
So key takeaways from this session. Basically, GitOps is a practice, not a tool. There are many tools that implement it, ArgoCD, FluxCD, but GitOps equals Git as your source of truth for continuous reconciliation, as you just saw in the demo that Scanned built. ArgoCD pulls the desired state from that Git repo, doesn't push credentials, so that makes it more secure and more scalable. We ship ArgoCD as a supervisor service with VKS, with the VCF platform, and it is a first-class citizen. Like I said, we've done some customizations to make it fit our multi-tenant model. The app of apps pattern inside of ArgoCD specifically allows you to have an entire fleet end-to-end managed through a single repository that's straight from clusters to add-ons to the applications themselves. Add-on management in VKS 3.5 and above, and we keep getting more and more add-ons as the new versions keep coming out. Allow you to create those packages as supervisor CRDs, which also means that they're end-to-end GitOps interoperable, and everything is in YAML, everything is in Git, and that means that it's all auditable end-to-end. Your hardware muted, Hugo. Hugo, we can't. Yeah.
Oh, sorry. There was a question for you, Miles. How to position Carvel KApp controller CD framework against Argo CD approach in VCF and VKS?
Yeah, I went through the questions and I noticed Frantisek was asking a bunch sort of around Carvel, ArgoCD, that kind of thing. So I will say keep an eye on VKS add-ons news going forward, because we're going to be supporting other frameworks, not just Carvel, very popular open source frameworks, let's say. So I don't think that there's any positioning that needs to be done, to tell you the truth. Like, KApp controller is fine, it does its job. But it's just another thing that can be delivered by ArgoCD. ArgoCD will use whatever YAML manifest you have, whatever tools you have. And like Hugo said, there's a blog from Navneet there on how to actually use Carvel tooling with ArgoCD. The more common pattern, honestly, is to use Helm charts. And like I said, just keep an eye on our VKS add-ons announcements going forward.
Thanks, Miles. Erica, back to you.
Thank you all so much. And again, that was recorded, and on my end, it was in 1080p. So for the recording, it should be as well. And we'll be posting that to YouTube following this. So thanks everyone with your patience on technology today. I know sometimes Zoom throttles things for folks. But thank you. This has been a great Kubernetes level up session number 2. We will be sending everyone the link to all of the recordings today on YouTube following this, and then we will work to schedule session 3. We don't have a date right now, but again, if you have feedback, please let us know. We'll be deploying a survey via email. It also may pop up in the lobby shortly. So if you'll fill that out, that helps us bring content for session 3 and 4, and also bring other relevant content. Loved the idea of doing other deep dives into other Broadcom products. So again, thanks everyone for being here. We're very grateful to have you. If this was your first VMUG event, welcome. This is what we're all about. And thank you so much for our presenters for their generous time today. Hope everyone has a great rest of their day, and we'll be in touch soon. Bye, everyone.